Hi everyone, and welcome to this video on equivalent expressions, a continuation of the algebra scheme. I am Darren, the Maths Guru, and it is always good to see you. Now remember, maths is a big fat trick, and this whole video series is about helping you decode how stupid maths can be. Yes, I actually am saying that. A maths teacher who says math is stupid because some muppet in a room is trying to make this really hard for you by using stupid language. We're going to decode that language in this particular course. Now, if you haven't already done so, there is a little doohickey in the corner, which would be grateful if you could click and subscribe. If you're watching this on maffsguru.com, it's really good that you've headed over there. It's a great place for you to look for videos and search and be able to sort of follow a course through. YouTube is amazing. Thank you very much, YouTube, but not very easy to sort these videos for education. So if you haven't already done so, head over to maffsguru.com. Sign up, it's free, and hopefully you'll enjoy the videos over there. Right, by the end of this lesson, what I want you to know, well, hopefully you'll have an understanding of the concepts of what it means to be equivalent, what it means to identify equivalent expressions, and if you need to, use a table of values. Now in previous lessons, as you can see here, and I love to do a bit of a recap at the start, what do we notice? Well, we've met the terms, and there's a lot of language in this. Term, coefficient, pronumeral, variable, constant. Evaluate, substitute, expression, and equation. If you haven't already watched the previous videos, I suggest just head back. They're about 20 minutes each video. You can watch them on double speed, which makes me sound really very odd. And you can just sort of catch up with the work before getting to this video. If you already know this stuff, don't worry about it. Now, the word we're going to look forward to using today is equivalent, and I again sound like a Sesame Street video. Equivalent. I'm the count, and I like to count. Today's word is equivalent. It really isn't, but anyway. So equivalent, and I love a dictionary. My mum made me use dictionaries all the time when I was a kid. If I didn't know a word, look it up, Darren. Thank you, mother. And so looking at equivalent, it's an adjective. That's very exciting. Thank you very much for telling me. I could hit that little button and play, but this is an image, so I can't. And what does it say? Equal in value, amount, function, meaning, etc. Equal in value. All of that word so that it means exactly the same. Yes. If it's equivalent, it has to be exactly the same. An apple is not the same as a banana. They are not equivalent. Hopefully a Granny Smith apple is exactly the same as a Granny Smith apple. Now I know there will be people out there going, well, no, not really, because what if the apple's bigger? What if it's smaller? A Granny Smith apple is the same as another Granny Smith apple. Leave it at that, not bothered about the size. Now again, I keep saying this to you, maths is a big fat trick, and we've got to get over that. Because we actually as maths teachers try and trick you by just changing the order of stuff. In fact, it's one of the easiest things we can actually do. So if you look at this example here, is 3 plus 4 different from 4 plus 3? Well, the order is different, but will the answer be different? Now, because 3 plus 4 is 7, 4 plus 3 is 7, and so both of these here, both of these expressions, not equations, both of these expressions are equivalent. They're the same. They give the same answer. What about another example? Let's throw some timesy stuff in it. What about this one here? 1 times 2 times 3. Is that the same as 2 times 3 times 1? Well, let's check. 1 times 2 times 3. Well, 1 times 2 is 2. 2 times 3 is 6. Hey, what about 2 times 3 times 1? Well, 2 times 3 is 6, times 1 is 6. Well, hey! And in fact, therefore, they are equivalent expressions, or they're certainly equivalent. But in the same way as 1 times 3 times 2, 2 times 1 times 3, all of those are in fact equal to 6. The learning from this particular thing is where things are connected by kissy kisses. Again, I'm coming back to the kissy kissy thing. Or timeses. So long as there are no pluses or minuses in between any of them, and they are all stuck together by timeses, we can change the order of the letters, or in fact, the numbers around. Okay, so knowing that type of stuff is really, really important. Now, doing it with numbers and doing it with letters, people are like, oh, letters confuse me. Don't. Think of the letters as physical things, as actual things from a supermarket. So for example, are the following the same? A plus B and B plus A. Now I'm sitting there saying, well, A plus B could be apple and a banana. So apple and a banana, is that the same as a banana and an apple? Well, I should hope so, yes. A banana and an apple. If I've got a banana and apple in my shopping trolley, then I've got an apple or banana, or I've got a banana or an apple. The order in that situation doesn't actually matter. So they are, in fact, the same. Yes, they are equivalent. What about the next one? All right, now again, do you notice how I keep giving these things actual stuff? 2a plus h. 2 apples and a horse. Okay, so there I've got 2 apples and a horse. What about the next one? 2h plus a. 2 horses and an apple. It just doesn't sound the same, does it? And it isn't, because 2 apples and a horse, 2 horses and an apple, they are not the same. So they are not equivalent. Moving up. Still trying to confuse you. I've got 3 things here. Which 2 of these are the same? I've got a plus h. So a plus h. I've got an apple and a horse. Okay, I can write that simpler by saying I've got 2 apples and a horse. Oh, writing it simpler has actually then told me, well, hold on a moment. Is that the same as 2a plus h? It is. But what about h plus 2a? Are they all the same? Yes, they are. I've got an apple and a horse, or 2 apples and a horse, or a horse and 2 apples. Saying these things out loud, and that's the trick to algebra, means it gets so much better. Now, I actually say, I play this game at school all the time. When I went to the greengrocer, I brought an apple. What did you buy? And the idea is the next person says, oh, when I go to the greengrocer, I bought a banana and an apple. And then a carrot, a banana, and an apple. A dog, a carrot, a banana, and an apple. And so basically the next person buys the next letter of the alphabet and remembers all of the previous people, and they go backwards. It's a funny game to play, lasts about half an hour. People get very frustrated, particularly when you get monkeys and stuff in supermarkets, and elephants and hippopotamuses. It's a very strange supermarket. But again, the reason I love playing the game is it gives people the idea that letters can be, just think of them as actual things. Right. Which of the 2 expressions are equivalent? This question's been taken from the Cambridge Essentials textbook series. Thank you very much, Cambridge, for letting me use your work. It's brilliant. So which of these are equivalent? All right, we've got 3x plus 4. We have 8 minus x. And we have 2x plus 4 plus x. Right, okay. So what does x stand for? What can we have x stand for? I think xylophones. Okie dokie. So in this one here, I've got 3 xylophones plus 4. 4 what? Well, let's just have it 4. Let's just have numbers without letters are just things on their own. So I've got 3 x's and the number 4. Okay. Well, look at the x one. I've got 8 minus x. Is the number the same? Well, no. I've got plus 4 in this first expression, but I've got 8 in the next one. And I've got minus a xylophone. So I've got 8 minus a xylophone. I don't know about you, there is no way that these 2 here look even vaguely the same. I can't make them look the same. It doesn't make any sense. So let's hope that the next one is the equivalent expression. I've got 2 xylophones. I've got a plus 4 and I've got another xylophone. Well, hold on a moment. I can add this stuff together. I've just said I've got 2 xylophones and I've got another xylophone. So I've got 2 xylophones and I've got another xylophone. How many xylophones have I got in total? I have 3 xylophones. And that just leaves this plus 4 on the end. And whoa, what do we notice? 3x plus 4 on the start and 3x plus 4 on the end. They are my equivalent expressions. Now, lots of people go, yeah, but that's confusing. How do I test this? By using a table of results. Well, you can do that. I just need to try and remember 3x plus 4. So what I'm going to write here is 3x plus 4, 8 minus x, and I think it was 2x plus 4 plus x. Right, so I don't have a table at the moment. What I'm going to do is I'm going to say, well, let's actually have a go at putting some x values in. 1, 2, 3, and 4. Let's do that. I'm just going to substitute some values in. Now, we know how to substitute now. Take the x out, put the number back in. So 3x's plus 4. So let's x equals 1. So 3x's. 3 ones are 3. Add on the 4 will give me 7. What about when x is 2? Well, 3 times x is 6, plus the 4 gives me 10. And I can keep going along, and I get the number 7, 10, 13, and 16. Right, next one. We're now going to do 8 minus x. So in this situation, first one, we've got 8 minus 1, which gives me 7. Well, they're the same. Yay, thank you very much. I found it. Tricked. All the numbers have to be the same. 8 minus 2 gives me 6, and then 5, and then 4. And I automatically can see there, doesn't work. Right, 2x's plus 4 plus another x. Well, 2x's, if we're letting this first one be x equals 1, then I've got 2x's, which is 2 times 1, which is 2, plus 4, which is 6, plus x, which is 1, gives me 7. What about the next one? 2x's. Well, x is now 2, so 2 2's are 4, plus 4 gives me 8, plus 2 gives me 10. And in fact, if I continue, I work out, using my table, that 3x plus 4 and 2x plus 4 plus x are in fact exactly the same. Ladies and gentlemen, a much shorter video, this time on equivalent expressions. You are looking for these things to be exactly the same, but we're going to try and trick you. We're going to try and write the letters the wrong way round. We're going to try and use 2a plus h rather than 2h plus a. The trick is, try and think of a supermarket. Think of stuff that you're going to buy in a supermarket and you will ace this stuff. All right, I'm done. Thank you very much for taking the time in watching this video. It is, as ever, brilliant seeing you. If you haven't already done so, can you click the little doohickey in the corner and subscribe to my YouTube channel and let your mates know that the videos are here and hopefully pretty good. Okay, it's good seeing you. I'm signing off until I see you in our next video. All right, take care. Maths Guru, signing out. Bye-bye.